enabling next generation helium and phase array system condition. Definition: electronic warfare LU system often require one instantaneous waves equals from frequency range 28. Any human process converted a broadband and mixes on a starting basic band interface now simpler LU system design, use and deployment. Topic 1. Similar and integrated single access transceiver provide alternative of small size, low power LU solution. This webcast delivers the benefits of this device to those interested in engineering and edge in the LU industry. Topic 2.
In antenna theory, a phased array usually means an electronically scanned array. An array of antennas which creates a beam of radio waves which can be electronically steered to point in different directions, without moving the antennas. In an array antenna, the radio frequency current from the transmitter is fed to the individual antennas with the correct phase relationship, so that the radio waves from the separate antennas add together to increase the radiation in a desired direction, while canceling to suppress radiation in undesired directions. In a phased array, the power from the transmitter is fed to the antennas through devices called phase shifters, controlled by a computer system, which can alter the phase electronically, thus steering the beam of radio waves to a different direction. Since the array must consist of many small antennas, sometimes thousands, to achieve high gain, phased arrays are mainly practical at the high-frequency end of the radio spectrum, in the UHF and microwave bands, in which the antenna elements are conveniently small. Phased arrays were first used in military radar systems to scan the radar beam quickly across the sky to detect planes and missiles. These phased array radar systems are now widely used, and phased arrays are spreading to civilian applications. The phased array principle is also used in acoustics, and phased arrays of acoustic transducers are used in medical ultrasound imaging scanners and military sonar systems. The term is also used to a lesser extent for unsteered array antennas in which the phase of the feed power and thus the radiation pattern of the antenna is fixed. For example, broadcast radio antennas consisting of multiple mass radiators fed so as to create a specific radiation pattern are also called phased arrays. A passive phased array, or passive electronically scanned array, PESA, is a phased array in which the antenna elements are connected to a single transmitter and/or receiver, as shown in the animation at top. PESAs are the most common type of phased array. An active phased array, or active electronically scanned array, ESA, is a phased array in which each antenna element has its own transmitter/receiver unit, all controlled by the computer. Active arrays are a more advanced, second-generation phased array technology which are used in military applications. Unlike PESAs, they can radiate multiple beams of radio waves at multiple frequencies in different directions simultaneously. A conformal antenna is a phased array in which the individual antennas, instead of being arranged in a flat plane, are mounted on a curved surface. The phase shifters compensate for the different path lengths of the waves due to the antenna element's varying position on the surface, allowing the
Applications. In applications in electronics, phased arrays antennas can be electronic stereo, which means the physical antenna can be stationary. This concept can eliminate of the on the hit gauge on gimbal in radar system. It can kick on antenna locking onto satellite when the antenna is mounting on moving on the platform. Topic one and topic one it is what allows on satellite to steer its being around your continent without having to deal with the sleep problem associated with training to pound things in space, very moment while recurring on opposite mass to moving in order to keep the satellite stable. And phase array receiver can flush mounted on the top of a commercial airplane fueling so that all the happy passengers can receive satellite television. And topic two.
Now, if you haven't heard of 5G, it is coming and it will be huge. It's going to change Earth as we know it, bring world peace, angels will be singing, and all things will be possible. Now, to enable this kind of bandwidth and data rates, we're going to have to do a lot of things in the RF and microwave communities, including antennas. And so these antennas are going to have to become very highly directive to save power and in order to get things localized well. So what we're thinking of is things like phased arrays, where the antennas, software, good antenna engineers designing them. But we have at AWR with Microwave Office have to enable a couple features to support this too. And I want to talk about a couple of those today. So we're not actually going to talk about the EM today for the antennas. Rather, we're going to talk about the circuit and system requirements. So let's think about this for a minute. If you're going to support antennas at a circuit level, meaning you've run the EM simulation, and you now, of course, need to excite the antenna, excite the S parameter file, a couple of things jump up at you. And in particular, I'm going to talk about today something called in situ antenna issues with circuit simulators. In a nutshell, as we get into it, here's the problem. You have an antenna array, and of course you're going to steer the array by changing the inputs, the power into the inputs, their power level and the relative phasing, and this is what steers the beam. This is how we steer an antenna beam. Well, all right, let's get going with the antenna. As I already mentioned, typically this is a problem when we have multiple inputs to our antenna. Now, usually that's a phased array, but you also actually have antennas that are a single antenna with multiple inputs. They're either changing the polarization or possibly the beam somehow. And these are typical antennas used in communication systems. We're going to see a lot more of them in 5G applications. Again, the antenna is going to affect the power amps feeding the antenna. And of course, the power amps then will change their performance, which will change the beam. We have to couple these together.
Pros and cons.
And analysis. I will talk about in that workflow. Talk about these arrays consist of 64 elements all the way up to 88 elements. I will present post-processing capabilities as beam steering, field visualization, and coupling data. Simulations took less than 6 hours. This includes adaptive meshing and the frequency sweep. And this is obviously all full wave simulations. Design workflow for 5G array could look something like this. So where you start off by designing the antenna element and then designing the phase array. And the next step would be that we are looking how this phase array would look like if the properties, how it would be if you put it into a casing. How would that affect the radiation patterns, for example? And if we take that casing and we put it on the mast, what would be the install performance? And we can take this radiation pattern and we can use them in SPR bus, and we can use them emit to look, for example, at link margin, RF interference, EMI, and we can show here that we have a base station on a tower of the radiate, all be simulated, the integrated board. So we may have different approach depending on what we are looking at. So if we are designing really large antenna arrays, so large that they can be considered infinite arrays. So how large it needs to be. So it could be, for example, 40 by 40 antenna array elements. In this case, you could say that the edge effects, they could be ignored compared to the rest of the array structure. And in this case, we could simulate it by using one antenna element in an infinite array environment. It would be that it has the same coupling in all directions. This technique requires low computational resources, is really effective when we have large structures.
The pros: ultrasonic phase array system can potentially be employed in almost any use-where conventional ultrasonic flow detector helps traditionally been used, or phase arrays can also be effectively used to profile remaining while thickness in corrosion survey application. Its cons, the potential disseminates or facial array system are somewhat higher costs and requirement for operator training. However, these costs are requiring of the builder rate, flexibility, and the reduction in the time required to perform an hybrid inspection. In conclusion, the benefits of phase array technology over conventional UT come from its ability to use multiple elements to stir focus and scan beams without sign and sign introducer ensemble. Beam steering, commonly referred to sexual scanning, can be used for mapping components at appropriate angles. Thank you.